Hi, I'm Steve Edwards, Director of Secure Embedded Solutions at Curtiss-Wright Defense Solutions, and I'm here with you virtually to discuss the importance of establishing a trusted supply chain. Counterfeit parts. These words keep our government, system integrators, and sub-tier vendors awake at night. We've all seen the headlines about sensitive electronic equipment failing due to counterfeit components entering the supply chain, or about electronic bugs being added to equipment. How do we ensure that our products do not have counterfeit parts and will work reliably over the deployed lifecycle of modern systems? In today's world, threats to deployed embedded systems are unending and constantly evolving. COTS vendors and system designers must remain constantly vigilant in order to protect and verify the integrity of our supply chain. When it comes to establishing and maintaining a trusted supply chain, the key watchwords are vigilance and visibility. An old adage made popular by President Ronald Reagan remains words to the wise: trust but verify. For example, trust in your supplier's certification, but verify that their performance to ensure that they and any brokers and distributors that they use have demonstrated their commitment and adherence to counterfeit mitigation and prevention. For years, COTS vendors such as Curtiss-Wright have taken a leadership role in establishing state-of-the-art trusted computing processes for open architecture rugged modules used by the embedded computing industry. These processes are designed to reduce risk and mitigate malicious threats against hardware or data. I will be using some of Curtiss-Wright's lifecycle services as an example of best practices to provide an overview of the processes essential for protecting the supply chain of components used in the manufacture of embedded modules. Trusted supply chain processes need to address areas such as physical security, manufacturing security, component supply chain integrity, secure handling and chain of custody protection, product reliability, counterfeit parts mitigation, and parts inspection. So when establishing a secure supply chain, the first place to start is to only buy components directly from the OEM or through their authorized distribution channel or franchised sources. Control over the component chain of custody can only be ensured by purchasing through controlled, authorized channels. The same stringent controls that are applied to semiconductor device suppliers also apply to subsystem vendors, such as when purchasing third-party modules. In this case, the same requirements that govern the purchase of components must be flowed down to the module vendor. If the module vendor needs to go outside of acceptable channels, as defined by the COTS vendor's purchasing standards, they must notify the vendor for approval prior to proceeding. That way, the vendor has the ability to control how the components are sourced and purchased, under what conditions they were obtained, and what is acceptable in terms of any authentication, testing, or other requirements needed to establish the confidence to proceed. The embedded industry, by definition, produces products made with commercial parts that typically have short lifespans. The challenge is that these products are used by customers whose programs have very long lifetimes. When a part reaches end of life, the first point of mitigation is to identify whether a drop-in replacement part is available through a franchise distributor. If there is no drop-in replacement, the vendor should proactively pursue securing material via last-time buy in order to obtain franchise materials that will support the full life cycle of the customer's program. Executing a last-time buy enables the supply chain organization to minimize the risk of obsolescence and extend product life while avoiding the need to procure obsolete parts from brokers. In some cases, obsolete components can only be found through brokers that are secondary sources, unauthorized by the component OEM. The COTS vendor should only use components from these suppliers only when authorized sources are no longer available, and then only with the approval of the customer. A brokered part should never be used on a board without explicit customer approval. All parts from these suppliers should be tested at authorized third-party test facilities to ensure that they are authentic components that meet the original design specifications and have not been subject to prior use or tampering. Broker parts must also be subject to intense audits, and any device provided by a broker must be tested by internal or accredited labs in compliance with customer, supplier, and industry-mandated validation methods. All test reports should be reviewed by the COTS vendors, components, engineering, and quality teams prior to accepting the material into inventory. When an authenticated broker part is used, the COTS supplier must perform disciplined configuration control practices in order to ensure that the brokered part receives a unique part number. Any brokered material must be controlled and segregated from franchise components so that its source of origin is always clear. To stay informed and up to date, COTS vendors should be active participants on relatively relevant standards committees, such as the Society of Automotive Engineers, or SAE, AS 6081. This standard defines best practices and requirements for working with trusted broker partners. Under AS 6081, manufacturers must establish a quality management system and retain appropriate records for supply chain traceability. Any broker that a COTS vendor works with must be authenticated to stringent industry requirements, which should be reviewed internally. Also, all material must be authenticated before it is brought into the manufacturing site. Even then, before any part acquired through a broker can be placed on a customer's board, approval must first be obtained from the customer. The customer must always be provided with the option of whether or not to approve the authentication reports, ensuring that they are comfortable with the material. COTS vendors should implement controlled processes designed to prevent counterfeit parts in the supply chain at any point in the product lifecycle. For example, SAE standard AS 5553 standardizes practices on how to avoid, detect, mitigate, and dispose of counterfeit material. Compliance ensures that only approved suppliers are used who have been audited and monitored by the COTS vendor to provide an audit trail for all components used and to ensure their authenticity. Many of the best practices for counterfeit mitigation include methods, systems, and trend monitoring resulting from participation in industry committees. Leading the way in efforts to prevent counterfeiting is the SAE's G19 committee, along with various other industry consortia such as the Electronic Resellers Association International and the Independent Distributors of Electronics Association. The continued development and evolution of important standards and methods of practice results from ongoing, in-depth partnerships with suppliers and customers. And through the development of multidisciplinary counterfeit mitigation systems, new relevant regulatory standards are continually released. For example, SAE AS 6174 is a more recent standard that addresses how vendors ensure that the materials they acquire are authentic and conform to specifications. Non-electrical counterfeit mitigation has been added to this standard. To ensure that their supplier is staying up to date with the latest trends in underworld counterfeiting and the most up-to-date techniques for mitigating them, systems integrators should query their supplier about what industry organizations they are members of and which ones they actively monitor. Maintaining membership in and monitoring the latest proposals from committees such as SAE G19 is critical for staying ahead of the counterfeit game. It is also important for COTS suppliers to monitor counterfeit occurrences and share these occurrences via reporting bodies such as the US Government Industry Data Exchange Program, the UK's ESCO Council, and counterfeit mitigation suppliers such as the Electronic Resellers Association International. Active involvement and communication with these bodies is critical for reducing the risk posed by counterfeit parts. One proven way of verifying a COTS supplier's ability to mitigate counterfeits is to ask them what formal certification they have earned such as AS 5553, AS 6081, or ISO IEC 17025. SAE recently released a technical certification to their National Aerospace and Defense Contractors Accreditation Program Suite that provides technical acknowledgement via auditing that the supplier adheres to AS 5553 requirements. Robust mechanisms must also be in place to protect the COTS vendor's own manufacturing facilities. Curtiss-Wright manufactures its computer modules in the United States, Canada, and Europe. Employees working on the manufacturing floor are subject to background checks. As a condition of employment, they are ITAR cleared before they are allowed into work on the manufacturing site. All sites are accredited to handle ITAR information. In addition, our U.S. manufacturing site is a secure facility that can handle classified data and components. In addition to its own manufacturing capability, COTS vendors should use only trusted contract manufacturers. For example, when required for sensitive U.S. defense and aerospace programs, you should work with a contract manufacturer that is IPC validation certified as a Class 3 trusted source and has a long legacy of high performance in the military C4ISR sector. When working with a U.S. eyes only contractor, it's critical to ensure that all materials are U.S. eyes only based, including, for example, PCBs and metalwork. It is also critical to ensure that the contract manufacturer can and does adhere to all of the processes and standards that are used in the COTS vendor's own facilities. To ensure design integrity, vendors should be compliant to the U.S. DoD's Risk Management Framework, or RMF. RMF provides controls for the IT infrastructure in order to mitigate against unauthorized access, modification, loss, or theft of critical design information. Communications between COTS vendors and system integrators is key to the successful implementation of a trusted supply chain. One approach for improving communications is to establish a 24/7 web-based information portal that provides the system integrator with updates and visibility into what parts are approaching end of life, informs them about last time buy opportunities, and whether or not a drop-in replacement part is available. As an example, Curtiss-Wright has established its Total Lifecycle Management Services portal. It's an optional communication channel that enables customers to manage their trusted supply chain. It provides insight into what's coming down the pipeline from industry and serves as a vehicle for information such as reports and status of their secured material inventory. It also enables them to approve ECOs and changes online. So going back to President Reagan's trust but verify statement, we can see that through vigilance and adherence to industry standard best practices, we can avoid the use of counterfeit parts throughout the life cycle of our systems. It takes work, and we cannot let our guard down, but it can be done. Thanks very much for giving me this opportunity to talk to you today. Bye.